Hi everyone, my name is Palash Bharadwaj. I am a starting assistant professor at Rice University, and the goal of my lab, the short-term goal of my lab, is to create an electrically driven single photon source with a high efficiency. Why single photons? Because single photons are a key requirement of many quantum information processing protocols, and yet we don't have a source of single photons that does not require low temperatures or another laser to drive it, and so on. So I want to create a source that is small, cheap, room temperature, and electrically driven. My background is in scanning probe microscopy and optical antennas. I studied the interaction of single emitters like dye molecules and quantum dots with plasmonic antennas for my PhD. Another key result from my PhD days was the first demonstration of electrically excited surface plasmons using a low voltage technique. So I used an STM tip to launch plasmons on a metallic gold nanowire. More recently, I have been involved with two-dimensional optoelectronics, and we published a paper last year in Nature Nano where we showed that electrons tunneling across a barrier in an integrated device can lead to photon emission, which can be modulated up till a gigahertz in frequency. So that work, this bringing of an electrical interface to optical antennas, that is also part of my proposed research here at Rice. I want to realize electrically connected antennas, ones that I can drive electrically as transmitters, ones that I can shine light on and they rectify the light and give me a DC current out. And I also want to keep working on my core kind of competence, which is high resolution nanoscopy using tip enhanced techniques. So the goal is that we have 2D materials as grown, MOS2, graphene, boron nitride. We use scanning probe techniques to characterize them, defects in them, maybe even create defects in these structures, and then utilize these engineered defects for single photon emission in an electrically connected device.